I would think your employer probably shouldn't have, you know, but you could ask them. And it's definitely a good thought. Other thing you could do, it's not fun, trust me, okay? Sinus rinses. Not fun at all.
I had to get the allergy test twice. I had to get it when I was small in my back, and then the second time I had to get it in my arms.
Yeah. Do you have to get shots?
Yeah.
Okay.
You can't like scratch it.
Yep. I would definitely see about wearing the mask. Because, you know, if that's the only time it bothers is like when you're actually having to do some cleanup, you don't have to wear it all the time. Just when you know that you're going to have a whole lot of it throw up. You know, because I'm guessing that includes like any little pieces of fabric and everything that might be falling off the new furniture and everything. So, you know, that's stuff that's getting up in there, and the body's definitely going to recognize it as being foreign and try to expel it out and cause all the leaking and the runny nose, watery eyes, and everything. One of the other things that the body can do, the body can actually can produce more vessels. It can actually encourage growth of vessels into a tissue. Now, this can happen in times of like trauma. It can happen in healing processes. A time when it wouldn't be all that great to have growth of new vessels take place is what happens with cancers. Okay? When people have cancer, you know, one of the things that happens in this situation is the cells continuously grow and divide. Their mitosis never stops, which is why you end up with a lump, okay, from the cancers. You end up with something wrong in that tissue where the cancer is found because of constant mitosis. Now, that means cells are constantly hungry, and they will actually encourage the growth of the blood vessels into that tissue so that they're being supplied with their food source to continue growing and dividing and create the cancer. So, you know, it's very interesting what can happen. So locally, the tissues can affect the control, the growth, the movement of the fluids. We also have neural control, our autonomic nervous system. Note, sympathetic only. Which one am I not mentioning?
Parasympathetic.
Parasympathetic. Sympathetic fibers are going to have that ability to stimulate most of the vessels because in their structure that they have, they are innervated. When you look at these big vessels going into medium, going into small, they're innervated. They have a nerve fiber. So, sympathetic means getting it ready for something, the fight or flight. So that would, you know, if you think about it, you would think that that's going to affect the dilation and the constriction, okay? And you would think, well, wait a minute, does that mean I'm getting more blood flow? Well, it's sympathetic, so it's going to be dependent upon what is the issue that needs to be handled. So the way that the body does this, do you guys remember the baroreceptors off of the branching that's occurring? Okay, once again, based upon negative feedback, their goal, blood pressure changes, okay? Making sure that we keep our blood pressure in that range that we consider normal for the body. So that might mean increasing blood flow, decreasing blood flow, okay? So that's going to be a control that we find for blood pressure. Our chemo reflexes, the chemicals of the blood, and for the most part, that's going to be based on pH, which of course comes down to the oxygen and CO2. Okay, so hypoxemia. Any idea what that term is? Alex?
Low oxygen levels.
Low oxygen. So these chemoreceptors, okay, and if you remember, we have those in some of those bigger blood vessels also. They'll respond to oxygen levels. Hypercapnia is oxygen, pH, CO2. Acidosis, definitely the pH. Now, when we think about our breathing, we tend to think, oh, well, oxygen. So isn't my body going to respond to my oxygen levels? pH is going to be the determining factor for oxygen levels. So CO2, that's getting produced. Okay, as long as there is materials available for the cells to function, to carry out cellular respiration, CO2 is going to get produced. We have to get CO2 out, and guess what CO2 will do to the blood?
Change the pH.
Change the pH. So the acidosis, if pH levels go down, my oxygen level needs to go up. Now that sounds kind of weird, but we'll get into that in the respiratory chapter, and vice versa. So, in cases where it has to deal a lot of it with the pH level, usually we'll get constriction, usually blood pressure will rise. We'll need to make sure that perfusion in the lungs, meaning get the CO2 out, or actually, believe it or not, you may have to raise it sometimes. Get oxygen in, sometimes, woo, hold up on the oxygen. I know it sounds really weird, but we're going to get to that in the respiration chapter. So, breathing is actually affected by pH levels. pH levels in the blood can cause breathing to increase and decrease, which is very interesting. We have what's called a medullary ischemic reflex. The medulla, does everybody remember the medulla? So that's my medullary portion. Ischemic means I have decreased my blood flow. When something is ischemic, blood flow has been cut off. Okay? And the brain is where this is going to occur because the medulla is in the brain. The medulla oblongata. Do you remember that? Okay? So, this is an area that is monitoring its own blood supply. Remember how I talked about the brain stem was very primitive? Okay? It really is, it does so many things about our maintaining the internal environment to stay alive, that it's going to actually be monitoring its own blood flow. Now, one of the things that'll happen, it'll activate a corrective reflex. And meaning that if it determines not enough oxygen, okay, that it's going to make sure that it's going to get the oxygen, meaning it's going to control that blood flow. Now, sympathetic fibers are going to play a part, and this would affect my heart rate, because if I affect my heart rate, it's going to affect my breathing rate, and that's going to affect my blood pressure, which is going to affect my blood flow, and hopefully return it back to normal for that medulla. Another way that we control the blood flow, hormones. Do you guys remember the renin, angiotensin, aldosterone process that I kind of mentioned back when we were talking about blood? Sort of. Yeah. Okay. Well, this comes back to us now. It's going to come back to us when we get into the chapter on respiration. Now, you guys remember like aldosterone from that region of the adrenal gland? Remember how we had the cortex and we had the medulla, okay? And the cortex had those three zones, okay? And aldosterone was one of those hormones that got released, okay? And angiotensin, when we look at that, that was based on renin in blood, but then that has to go to the lungs to get converted so that in all of this, we get to adjust blood pressure. Now, you're sitting there looking at me like, oh, what? Okay. So as we move forward, because we're going to get into the respiratory system, we're going to get into the kidneys. Now, one of the things that I tried to point out is how when blood leaves the heart, goes over the arch and begins to descend, first thing it hits is kidneys. Kidneys are going to want to detect, and they are going to detect that oxygen level. The way that they're going to detect the oxygen level is based on the amount of red blood cells that are present. Because red blood cells hopefully are going to be carrying oxygen, right? Is everybody with me? So, the kidneys have the ability, because we should have a normal value of red blood cells that are available, meaning a normal oxygen, that hemoglobin, okay? So if the kidneys detect oxygen levels are not where they're supposed to be, they will release a hormone. And that goes to the bone marrow, which will stimulate that colony factor. Do you guys remember that? And that will give rise to more red blood cells. So that if I can produce more red blood cells, I have the ability to do more oxygen to get it to my tissues. My renin. Okay? And what we're going to find is, in cases where I need to affect this, I'm going to have my renin, which is going to stimulate angiotensin, which is going to have to go to the lungs, convert to angiotensin 2, and based on these factors that it picks up on, the goal, raise my blood pressure, increase the blood pressure. Now, this whole setup is done so that we can have some control over my blood flow. In cases when blood pressure drops, which would mean drop